My name is Ed Donelan. I've been in business for 30 years. My biggest success has been really in business with my wife, Laura, who's here somewhere. Somehow she's put up with me our CEO is over there. She's put up with me for 30 years. I've got about 40 years experience in wiring buildings. I started many, many moons ago in the electrical trade, and my dream was to wire buildings all over the world. I've been very fortunate to be able to concentrate most of our efforts here in New York City for the last 30 years, but we do have a national footprint. So you'll see after my name there's an RCDD, which is a credential. I was involved with BICSI. BICSI is a non-for-profit telecommunications association specializing in education and training and advocating credentials for over 25,000 people around the globe in 120 countries. I was on the board and president for 10 years and proud to serve that organization. I'm a firm believer in education and training. I believe it's absolutely essential for us to all remain competent in our industry, especially in technology, because believe me, we are in for one heck of a ride, as I'm about to show you regarding technology. So, 3 takeaways today, quite simply. I want you to understand a little bit more about DAS, both public and cellular. I want you to know where to go for help, obviously, and I want you to know about the wireless market opportunities for yourself and your tenants and your customers. So, simple takeaways. A DAS is a simple system. It's a bunch of wireless devices distributed throughout the building to give you either cell phone signal, I should say wireless signal for a variety of different devices. You're about to see a huge increase in devices going on, and also for first responders. We're going to talk a little bit about that. So why is DAS an interesting discussion today? If you look at these slides, you'll see 2 major takeaways. And that is the takeaway on the smartphones or intelligent wireless devices, which is the middle in gray. And there's a tremendous surge in wireless devices, as well as the stuff in blue, which is machine to machine. And that's where the building owner comes in. You're going to see machine-to-machine wireless devices take off. That's why Cisco's getting involved with the business, because they see an opportunity for wireless communications to automate the Internet of Things. More on that to come. So, why is it an interesting topic? Well, as we evolve, we've had several code changes that had led us to our DAS signal disruption, as well as first responder. The USGBC, the United States Green Building Council LEED certification, mandates that there be certain material put in buildings to make them energy efficient. We'll talk about that. FirstNet is a new spectrum, the 700 megahertz spectrum, that's going to be allowed the first responders, that's all the first responders, allowed to go up in their frequency range from 300 to 400 megahertz to 700 megahertz and have a more reliable system. We'll talk about that, as well as the unbelievable surge in cell phones and wireless devices influencing the marketplace. So who is responsible for the design? Who can you rely on to install it, maintain it? And how is the installation done? I'm going to answer some of those questions. And who is paying for this after all? It's not inexpensive. We're going to talk about the evolving landscape on what we got used to with funding and how things are changing here, especially in New York, very rapidly. So traditional systems, this is a donor antenna. We started installing donor antenna systems. By the way, they're really not condoned here in New York City because of the congestion. But a donor system has an antenna on the roof, and it goes to the macro tower, the cell tower, and it communicates this way. We started installing them in '99 when Y2K was prevalent. Here in the city, we do not use this sort of technique. However, in suburbia, the tri-state outer areas, donor antennas need to be coordinated closely with the carrier in order for this type of system to work. More prevalent here in Manhattan is the distributed antenna system that uses a base station, or BTS. And you'll see that located typically on the lower floor. Not always, but typically it's located close to the minimum point of entry. Now, some takeaways here is that it doesn't take the signal from the macro, the tower, that's already congested. It's taking the signal from the street, either fiber or in some cases microwave based. That's what we have here in Manhattan. There's two different envelopes in a building that you need to be concerned about. The riser envelope, which is going vertical, and the horizontal envelope, which is going horizontal. And I'll talk a little bit about that. But the cost associated with the base station can be upwards to $250,000 to put the mechanical, electrical, and telecommunications facilities in to accommodate the variety of carriers that we have. And Jeff is right. From our experience, we see mostly AT&T and Verizon in the buildings here. So public safety operates in a very similar manner as a DAS. However, where a typical floor space, say to 30 to 50,000 square feet, might have 8 to 12 antennas, a public safety system is going to have 4 to 6 antennas. It's a lower frequency, therefore it promulgates its signal a little bit greater penetration. You don't need as many antennas, but the architecture is a lot similar to DAS. So get ready, because one thing is very, very much needed in the implementation of these systems, and that is pathways and spaces. You simply do not have the pathways and spaces to accommodate the modern communication systems that we need to put in. And I would argue the fact that the fourth utility is not an amenity. It is an absolute necessity that we, in the New York marketplace, have to accommodate. We have to compete globally. We must enable broadband in a variety of different ways. That fourth utility, whether it's wired or wireless, must be accommodated here. I would like to propose that this is not an enhancement, which I know it is often thought of, or an amenity, but for the building owner to attract the tenant, for them to stay on board, they must have broadband connectivity. Can you imagine if I asked you to turn off your cell phones for 2,080 hours? Did you know that 80% of the connectivity that cell phones have, whether it be calls, traditional calls, or inquiries, 80% of that is made within a building? That's a phenomenal statistics. Did you also know that only 2 to 4% of our buildings are wired for in-building cellular? We've got a lot of work to do. So I think we need to make it a fourth utility, just like telecommunications has always been, but wireless is going to be essential. Pathways, spaces, mechanical, electrical are going to be key to our success. Now, there's a new innovative design technique that's going to alleviate some of the congestion for pathways and spaces, and this is what we call a collapsed star architecture, if you will. It's a DAS hotel. It also could be a Wi-Fi hotel, and it could be a first responder hotel. In other words, the equipment in that vertical envelope, the riser closet, would be connected to fiber optics and collapsed to basically a central office offering diversity, redundancy, and backup for the mechanical, electrical systems that we talked a little bit about what happened with Sandy. So there's a new topology happening here in Manhattan, and it started with really with the transit wireless. When they started to light up the subways, they realized they needed to backhaul the connectivity. We're seeing some DAS hotels being populated so that you as a building owner don't necessarily need to give up the critical space for the BTS. That can be co-located as well with Wi-Fi and first responders. So we'll be happy to share with some of the topologies. Now, I'm talking mostly today about commercial high-rise buildings, obviously, but I do give an illustration of some of the other venues that we're hooking up with wireless. So what's the bottom line? It really is about tenant improvement, tenant enhancement, and that's for existing buildings, certainly. A bit more of a challenge to install that, to retrofit that into the building. We're specialists in that area. We live for design build and new construction. Certainly, we're going to talk a little bit about the first responder, new construction, and DAS implementation coming up. So, yeah, it wasn't long ago that DAS really wasn't necessitated either by code or by the amount. There's little over 7 billion people on the planet Earth. And did you know that there's about 4.5 billion wireless devices currently connected? you saw some of the growth that's happening with regard to mobile. And I have some statistics to share with you. So get ready, because we're gonna really need to respond to the marketplace. But here's one thing that not a lot of people understand is that lead engineering, that USGBC lead certification requires you to put e-glass in your windows. And that's good for the lead certification, but it's bad for RF engineering, because typically in buildings here in the city, or any other city for that matter, you'll get signal from the first floor of the 20th floor if you don't have the lead of the e-glass. But from the 20th floor up, it's simply not able to communicate to the macro. Very often, if you're not putting those antennas up, you won't get signal. But if you have e-glass, you're dead in the water. I don't care if you're on the first floor or the fifth floor. That e-glass is going to prohibit the signal from coming through, just as it would keeping the solar and thermal control under for energy savings. It'll prohibit RF signal. So I'm going to talk a little bit about first responders. The code has changed, and it's changing rapidly, so that first responders, in our experiences, certainly out of the 9/11, have swept the country. And the code is the International Code Council, ICC, and the NFPA, National Fire Protection Association, Code 72, mandates that the first responders have ubiquitous coverage. Now, remember, back in the day, the first responders, what they did was they plugged into the elevator. There was a jack over by the elevator, and they used to communicate with hardwired communications, right? Well, that's somewhat antiquated. They all have RF devices, and their frequencies step on each other so that someone is overriding the other person, and the communication can't be there. Hence the need for a coordinated, frequency-responsive, in-building DAS system. So, of the IFC, the International Fire Code, Chapter 5, I took a couple of snapshots here. All new buildings should have approved radio coverage that are in the jurisdiction with public safety communications the same as at the exterior of the building. And Jeff shared with you some of the parameters for height and things of that nature. Where approved, the building official and fire code official, a wired communication shall be permitted. Now that's the old phone jack system that the fire chief will tell you. They don't use the phone jack system. So these are exceptions, though. If there's a hardwired system, there is an exception that exists for you. As well as where it's determined by the fire code official that the radio system coverage is not needed, this exception may be required at a minimum. An RF survey has to show that there is signal. Very often in these buildings, there is not signal on the upper floors. So if the building is more than 5 stories above ground plane, this is in the IFC. Local jurisdiction always has the authority to override national jurisdiction. So you'll see, I'm citing the International Fire Code. Manhattan has their own fire code, and the monitoring and the code is pretty strict. Not as strict as you see out on the West Coast, but somewhat restrictive. So these are general guidelines. There are floors. If there are floors used by human occupancy more than 30 feet below, you need a system as well. So those are some, or the building is more than 50,000 square feet. So where's the code today? Where is it populated around the country? You can see a lot of states have adopted the IFC. A lot of local municipalities have adopted their own code. And here in Manhattan, the New York Fire Department certainly has their own code that I would encourage you to get to know a little bit about. But it is reality. So I want to talk a little bit about the DAS funding models. Jeff had touched on this. I won't repeat a lot what he has said, but there are certain takeaways here. Carrier funded, long-term commitments. The signal source is very often paid. Carriers will pay for the building. However, there's a little thing going on called the spectrum auction. And last year, I've got a slide on this. Last year, the auction generated a little over $40 billion of revenue for the government to auction off airwaves. This coming year, they're auctioning off the 600 megahertz spectrum. Bottom line is, they're running out of money. And if they're funding the DAS today, you can bet that the DAS that was going to be funded will not be funded by them tomorrow. Hence, we need to have solutions to make your buildings intelligent. We need to use topologies like the DAS hotel, which minimize costs. We need to look at economic models that have to do with the CapEx and OpEx and leasing options to amortize some of the costs associated with these systems. Third-party venue, I'm going to talk a little bit about that, and enterprise model, capital expense with lease options. So, Carrier One, the model is funded by the carriers. We are certified with all the carriers. We have wired many buildings here with them leading the charge. And it is a long-term commitment. Very often it's 10 plus years that you're going to allow the carrier to have unlimited access to your space. Does this ring a bell? Is this history repeating itself? Because last I checked, back in the 70s and 80s, if the carrier owned the wire, they owned the customer and they were in your building and you granted them space. You didn't necessarily charge them for it, but now it's whoever owns the wireless spectrum owns the customer, right? But you have a choice to make down the road is, are they going to own your building? So that's something for you to think about. In many cases, it might be worth $2 million to $3 million to grant them those rights. That absolutely, and they're spending a lot of money on that spectrum, and they want to use it. You know, Verizon just bought AOL. Well, not just, it's old news, but they have good plans for delivering content on the airwaves to generate revenue. And all these systems do need to be licensed. You need to have reciprocal arrangements with the carriers, close carrier coordination. You cannot just simply put in a donor DAS or a BTS type DAS and not closely coordinate it with the carriers. So in this case, we have the second model, American Tower and Crown Castle is funding as well. He'll grant them space, long-term commitment. There are some legal issues, which Jeff is more than happy to take care of for you. And there is very little control over your building. The third model is really an enterprise model that has a true neutral host that allows all four carriers. And you're going to see why this is important to allow all four carriers, not so much for the enterprise model, but it is a model that I would implore you to start to look at, because some of the funding models that are traditional will be drying up. There are direct negotiations between the building owner and the representative. The representative typically will negotiate on your behalf with the carriers, with his or own choosing, and there is a lease option to kind of amortize some of the costs that are associated with it. And from what I understand, with the public safety system, you can put the public safety system into the common core charges of a lease arrangement, but you necessarily can't do that with an in-building DAS system. So it's a little different way that you can handle the expense with a first responder system. You can kind of pass some of those costs off, but it's difficult with DAS. So keep that in mind. So the enterprise neutral host, and this is kind of where we get down the boilerplate 101. These are kind of the base station on your left, which is carrier owned. In every case, there's typically 2 to 3, perhaps 4 carriers in the base station, wherever that exists. And then there's the building owned leased, which is the riser component in your riser closets. Many times pathways and spaces are not readily available. We have to make them. We specialize in taking out a lot of the old copper cable plant or the old switch gear that was in there, the old 1A2 switch gear, making the pathways for the remote units, as they're known as. And then there's, in traditional architecture, there's half-inch helix coax, which is very unforgiving, very heavy, and very time-consuming to put in. These are finely tuned, very sophisticated electronic signaling systems that are put in. It's not like your traditional unshielded twisted pair. It can take a beating and still keep kind of working. This is a very sophisticated system. So I say that because it's not only important from a day 1, day 2 perspective, it's got to be something that's going to last. Not only is it going to last when you do retrofits, restacks, and upgrades, but it also has to be on the upgrade. You know, historically, we went from 2G to 3G to 4G. We're at 4G now, and actually we're at 4G LTE with the advanced wireless system. we're going to 5G. So a little bit on 5G coming up, but it is evolving, and it is amazing how much bandwidth you can get out of it. Imagine being disconnected for 2,080 hours in your building. If you do not have an in-building cellular, your customers simply feel very uneasy. You've turned your phone off for 2,000 hours. I'm sure you'd feel uncomfortable. So I mentioned 80% of the phone calls are made within buildings. That's phone calls and interactive apps and things of that nature. That's a phenomenal amount, 2 to 4%. We've got a lot of work to do. And you can just ask yourself the questions, are these types of smart devices becoming more or less relevant in people's lives? Are there more apps out there that are coming to help you as a building owner or a building manager, a building professional, real estate professional, enabling you to do your job better? Absolutely. There's apps coming out with building automation, environmental control. There's apps coming out for real estate development and things of that nature. So these devices are only beginning to become more and more popular. The bring your own device phenomenon that's sweeping the enterprise, quite frankly, corporate America is changing their philosophy in supplying cell phones to all their employees, and they're allowing people to bring whatever they have. So if you are allowed to bring it and you have to pay for it, you might get a subsidy for the payment of that phone. You're going to choose a economical carrier. So when you have a BYOD policy, you're going to see choice, and those people are going to want to be connected. So 40% of the devices have access to corporate networks are personal. So you're going to be looking at different carriers. Today there's 4 common carriers here in America, and they're all competing for your business. And those plans change every 3 months. It seems like Apple just announced that they're selling phones, and you can pick a carrier every year. So in direct competition with AT&T and Verizon. So everyone has the bottom line to make, but it's important with regard to bring your own device to work that when it gets there, it actually works. So I want to talk a little bit about my company. We're here in the city for 30 years. We're located on 42nd and Lex. So we're all experienced professionals. They're all Bixby trained. We also have certifications in a lot of the required design criteria. One of those requirements is an IB Wave certification, which is a design credential that you have to have in order to properly design it. We are designing in-building cellular systems for our customers in a variety of different venues. But the IB Wave certification is a pretty significant undertaking in terms of capital investment. I'll show you what that does. Before I do that, I wanted to share with you we've wired in-building DAS here for 15 years now and done several hundred buildings in and around the tri-state area. But recently we completed some of these buildings here that you see on your left. And each one poses a particular challenge. In particular, I know that, we just recently completed 4 World Trade, when that 76 floors has over 700 antennas. But the old Condé Nast building, 4 Times Square, we had an opportunity to do that just before the Super Bowl, and they asked us to get it done. Typically, it takes 6 to 8 months to wire an in-building DAS system of 2 million square feet. They asked us to do it in 6 weeks. Super Bowl was coming. We said, no problem. We figured out a way to make it happen. It's an old saying here in the city, take your time, hurry up. And that's what we did. So Prudential Arena, many malls, many locations around the area, we've been able to integrate our systems with carriers and with neutral host providers, as well as third-party providers. So this is a little bit about the 12 steps to designing, and actually there's 27 steps, and I can't get into it today, but there's 27 steps that we've identified that are absolutely critical to putting in an in-building DAS. But if you start at the top in the blue, the DAS need identification, the budgetary quote, you can use $2 a square foot, by the way, as a good budgetary number for how much your DAS is gonna come in at. And it could be more expensive. That's just for the DAS. That's not the mechanical, electrical, the air conditioning, and the electrical that might be needed. That's just for the DAS itself. But $2 is a good number, but what we want to do is work with you and conduct a site survey. design an initial design and a bill of materials. And this is where the kind of the rubber hits the road. Do a detailed design and then a final site survey, the final design and building materials. And we bring this initial design to the carriers to see the level of interest. A statement of work, a carrier approval, installation and commissioning and acceptance. And all this takes a great deal of time. Typically it takes a year or two in order to undertake the carrier funding. If you wanted to get your DAS lit up in a few months, I would say that's pretty much impossible to get carrier funding for that. They simply have a budget cycle and they need to anticipate those needs. If you use the enterprise model, you can get it done fairly quickly. What you see in the upper right hand is your floor plan. Down in the lower right hand is what we call a heat map. This is that 97% availability of both first responder, and this is the same type of design for first responder as well. The heat map is in particular given on different frequencies for the different providers. And then there's a typical VTS on the upper left. So some of our other services that we provide is professional design, project management, traditional structured cabling for tenant wiring. We do an awful lot of AV and a lot of electronic safety and security and CCTV and access control. I wanted to share that with you. What's coming is the Internet of Things. The recent spectrum auction that I mentioned, believe me, when you spend $42 billion in spectrum, and you're going to spend upwards, they project $60 to $80 billion next year in auction of the spectrum, you're going to use that. So the Internet of Things are going to drive a revolutionary change for us here in the city. Machine-to-machine connections will be the drivers for productivity and efficiency. By 2017, you'll see a 34% increase in tablets on cell networks as the primary method of connectivity. So the traditional desktop computer is going away. It is going, I see a couple of heads shaking out there. You sense that as well. By 2018, it's projected that traffic from mobile and wireless will exceed wired connections. Man, am I glad there's a lot of wire and wireless. So the FCC is really, I guess that's how they're paying for all the money that the bankers printed at the Fed. And they're auctioning off the spectrum and they're getting billions and millions of dollars. But in any case, they're expecting a huge auction next year in the 600 megahertz bandwidth. And even though that's a low frequency bandwidth and not all that attractive to the carriers, they're more up to the higher frequencies for more data. The lower frequency can have a further penetration. So that is going to be interesting to see what happens there. A little bit about 5G, some statistics. We're going to be wrapping up here shortly. 1,000 times higher mobile volume, 10 to 100 times the number of connected devices. We need 5G. The networks are getting saturated. 10 to 100 times the typical user data rate. I purposely left out the slides Wi-Fi, but I wanted to talk to you a little bit about Wi-Fi because a lot that's happening in cellular is happening in Wi-Fi. Wi-Fi is unlicensed spectrum, and it's very popular. Many people who come into a particular facility want to attach onto Wi-Fi rather than cellular because of the data rate, the usage plans. Wi-Fi is about to undergo a revolutionary change too. There's three phases of what the IEEE calls 802.11 AC, which is a fancy name for a protocol Wi-Fi. On the third phase of this implementation, which is yet to really be deployed, there's power over Ethernet for the antenna. There's two cables run to the antenna, and the antenna is using a very sophisticated beam-forming method of connectivity, and it gives the user up to 1 gigabit. That's 1 billion bits per second of connectivity. So where you have 1 gig now, traditionally on Category 5, Category 6 cable, you're going to get that on Wi-Fi. When 802.11 AC gets mature, it's going to drive the antennas, but here's the caveat. The signal does not travel very well. It's high frequency, but you need an antenna in just about every room. I mean, a 10 by 10 office, 100 square foot office space. So there's going to be a lot more Wi-Fi access points in the future. So get ready for pathways and space challenges. Get ready for more Wi-Fi antennas, because at 1 gig, it truly does compete with cellular. So, in summary, we're excited to be hosting this event today. I believe we brought together some really great speakers, and American Tower is coming up next to speak. But what we wanted to do is to be able to offer you an opportunity to say, hey, Ed, Telecom, we want to just take a preliminary look at our buildings or our building and take a look at solving some of the issues. We're experts in that arena. So I wanted to offer a complimentary building and DAS assessment. There's no obligation. It would be something that we'd come in and do that preliminary budget for you. We do need 4 things from you, though. If you wanted to take us up on the opportunity, you can contact us at any time. Our needs are pretty simple. We need to know the square footage per floor. We need to know the number of floors that you have. We need to, hopefully, if you have prints in CAD, that'd be great. If you have them in PDF, we'll take them. And we need to know the kind of technologies that you're interested in using. Carriers, the frequencies. We'll figure out the frequencies, but the carriers that you're interested in. And by the way, one note on frequencies, a lot of the carriers are getting rid of the older technology and forcing your phone into phone antiquity. So anybody with like a flip phone, they won't be working in the years to come very soon. But even if you don't stay current on the latest phone edition, some of those older phones will not be supported with the carriers. It's simply too costly for them to support all the technologies, especially the legacy technologies. So you should know that. And we just need to know about public safety and some of the other needs, especially in hospitals. There's two-way paging and Wi-Fi. Everyone needs Wi-Fi. So those are some of the techniques. So I want to thank you. I want to take any questions you might have. Thank you.